Networking is the most critical component for any IT infrastructure. Networking is the fundamentals and the backbone for virtual machines, databases, applications, load balancers, etc. There are different situations where we need to manage the traffic between various entities. The traffic could be flowing between the virtual machines in the same subnet, or it could be between virtual machines in different subnets in the same virtual network. There will be data flow from the virtual machines to the internet, and then the communication between virtual machines using a VNet to VNet VPN. Not to forget, we may also have site to site and express route communication through the VPN gateway. All such kinds of communications that we just listed here are managed by something called as system routes. Azure uses system routes to direct network traffic between virtual machines, on-premise networks, and the internet. Consider a virtual network with two subnets. Communication between the subnets and from the front end to the internet are all managed by Azure using the default system routes. Information about the system routes is recorded in something called as a route table. A route table contains a set of rules called as routes, and that specifies how the packets should be routed in a virtual network. Route tables are associated to subnets, and each packet leaving a subnet is handled based on the associated route table. Packets are then matched to routes using the destination. The destination in a network can be an IP address, a virtual network gateway, a virtual appliance, or even the internet. When the traffic is directed to a destination, if the matching in the system route is not found, then the packet is dropped. System routes are automatically created and managed by Azure. They are assigned to each subnet in a virtual network. You cannot create system routes, you cannot remove the system routes, but you can definitely override those system routes using something called as custom routes or user-defined routes. Azure creates default system routes for each subnet and adds additional default routes to specific subnets or every subnet when you use specific Azure capabilities. Azure automatically handles all the network traffic routing. But what if you want to do something different? For example, you may have a virtual machine that performs a network function such as routing, maybe firewalling, or probably WAN optimization. You may want certain subnet traffic to be directed to this virtual appliance first and then redirect the traffic somewhere else. For example, you might place an appliance between the subnets or a subnet and the internet. In these situations where you want to customize the way Azure routes the traffic, you might choose to configure a user-defined route, also called as a UDR. UDRs control network traffic by defining routes that specify the next hop of the traffic flow. This hop can be a virtual network gateway, virtual network appliance, or a virtual network or even internet. Each route table can be associated to multiple subnets, but a subnet can only be associated to a single route table. Keep in mind there are no additional charges for creating route tables in Microsoft. Let's go ahead and take a look at these in the Azure portal here. I'm currently logged into the Azure portal and then search for the route tables under my subscription. I'll click on the Create Route Table button. When you click on the Create Route Table button, you're actually creating a user-defined custom route. So I'm going to write this as custom route. So I'm going to write the name as custom route and then select the resource group and then leave these options default here and then click on Create. There you go. So now my custom route is created. I can go and click on Routes and then Add and user-defined route. Define the route name as to say Route 1 and the address prefix. This is the source from where the traffic will be originated. And this one, for example, it will be the CIDR block of my subnet. So I will type the CIDR block of my subnet as, let's say 192.168.30.0/24. There you go. Now, if the traffic originates from this particular CIDR block, what should be the next hop? You can define that in the next option here. The next hop can be a virtual network gateway, the next virtual network, internet, virtual appliance, or if you want the packets to be dropped, then you will just select none. You have various options here. That means that any traffic that will be originating from this adder block will be going to the internet if I select internet. So thereby you're customizing, modifying the way Azure defines the routes by default. These are called as user-defined or custom routes. Let's think about a specific scenario where let's say you got subnets and they are private, there are few subnets in DMZ and some of them are in public. So in the DMZ subnet, there is let's say a network virtual appliance, and that network virtual appliance is a virtual machine that will be acting like a network function or maybe a router or a firewall. So if you want that traffic from your subnet to go to the virtual appliance first, then you will select that particular appliance IP address. So any traffic that is, let's say, originated from 192.168.30.0 slash 24 will be going to the appliance IP address, which is, let's say, 192.168.30.20, right? So that ways, this particular firewall, which is a virtual appliance, will be able to capture all the traffic originated from this CIDR block. By doing so, you're ensuring that all the traffic from that subnet, let's say a public subnet, will go through this virtual appliance to a private subnet. So what is a user-defined route? A user-defined route is a custom route. If you want to change the way Azure handles the network traffic routing and you want to do something different, then you will be using user-defined routes by adding your own routes and then assigning them to the subnets. Now I will go ahead and finish this configuration here, call it as route 2 or something, and then click on OK. We also need to see how you can assign this route to the subnet. Okay, so I will go to the virtual network that we created called as mysite-vnet, and then click on subnets, identify my subnet that I want to assign to, and then under route table I should be able to find the custom route that we just created. So that means any device that is hosted in the subnet will be going through the route table that we just assigned to the subnet. So thereby we are enforcing the traffic to go through the device that is defined here. So the next hop will be 192.168.30.20 for all the devices in this subnet.
When you create web applications, you need to ensure that the users get 100% uptime for the web applications they are accessing. This cannot be achieved with a single web server because if that web server is down for maintenance purposes, patching, or for any other reason, then the end users will have difficulty accessing the application hosted on the web server. For redundancy purposes, organizations would create multiple web servers and put them behind a load balancer. The load balancer absorbs the traffic and evenly distributes the traffic originating from various regions to the web servers hosted in your data center. Azure provides this service with a service offering called Azure Load Balancer. The Azure Load Balancer ensures that the applications hosted on your data center are highly available. The Azure Load Balancer can be used for traffic originating from the internet and also for the intranet-based applications. So the purpose of the load balancer is to distribute the traffic to the virtual machines configured in the backend pool created in Azure Console.
Azure Load Balancer delivers high availability and network performance to your applications. The load balancer distributes inbound traffic to backend resources using load balancing rules and health probes. Load balancing rules will determine how the traffic is distributed to the backend. The health probes ensures that the resources in the backend are healthy. The resources could be virtual machines or even apps. The load balancer can be used for inbound as well as outbound scenarios, and it can scale up to millions of TCP and UDP data flows. Always keep this diagram in mind when you think about load balancer. As you see, there are four components here that must be configured for your load balancer, and we'll take a look at that when we do the labs. So there is a front-end IP configuration. There's a back-end pool that consists of virtual machines in this case. Then there are health probes that will constantly probe the back-end pool to identify whether the virtual machines are healthy or not. Are they listening on a particular port, like port number 80 maybe? And then you also define the load balancing rules. Let's talk more about public load balancer and internal load balancers in the upcoming lessons. There are two types of load balancers, public and internal. A public load balancer maps the public IP address and the port number of the incoming traffic to the private IP address and the port number of a virtual machine. By applying the load balancing rules, you can distribute specific types of traffic across multiple virtual machines or services. For example, you can spread the load of incoming web request traffic across multiple web servers. The picture here shows internet clients sending web page requests to the public IP address of a web app on TCP port number 80. Azure Load Balancer distributes the request across the three virtual machines in the load balanced set. This is an example of a public load balancer. A public load balancer is exposed to the internet on the port that you define. It will then have a backend pool with a pool of virtual machines which are communicating with the load balancer on a port that you define. So there's a lot of customization that you can do, but at this point just remember that public load balancer is exposed to internet usually for web applications on port number 443. Let's talk about the internal load balancer aspects in the next lesson. An internal load balancer directs traffic only to the resources that are inside a virtual network. An internal load balancer can also be used via a VPN to access Azure infrastructure. The front end IP address and the virtual networks are never directly exposed to an internet endpoint. Internal line of business applications run in Azure and are accessed from within Azure or from your on-premise resources. For example, an internal load balancer could receive database requests that needs to be distributed to backend SQL servers. If you look at the picture here, the virtual machines are communicating with the internal SQL servers with the help of a load balancer. The load balancer then distributes the traffic to the backend SQL servers on port number 1443. That means that an internal load balancer will help us achieve different kinds of load balancing. It could be load balancing from virtual machines in a virtual network to a set of virtual machines that reside within the same virtual network. It could also load balance from an on-premise computer to a set of virtual machines that reside within the same virtual network. For multi-tier applications, the internal load balancer can load balance for internet-facing multi-tier applications where the backend tiers are not internet-facing. The backend tiers require traffic load balancing from the internet-facing tier. The internal load balancer can also balance the load for all the line of business applications that are hosted in Azure without any additional load balancer hardware or software. Now, this scenario includes on-premise servers that are in the set of computers whose traffic is load balanced. A public load balancer could be placed in front of the internal load balancer to create a multi-tier application. Let's take a look at different characteristics of the load balancer in the next lesson. When you create an Azure load balancer, you will select the type of load balancer. It could be internal or public. You can also select the SKU of the load balancer. Let's understand what is a load balancer SKU. The load balancer supports basic and standard versions of SKUs, and each of these differ in scale scenarios or different features and pricing as well. The standard load balancer is the newer load balancer product with an expanded and more granular feature set as compared to basic load balancer. Let's talk about some general information about SKUs. Keep in mind that SKU of a load balancer cannot be changed once it is created. A load balancer rule cannot span across two virtual networks. That means that you cannot have virtual machines sitting in two different virtual networks and connect them with one single load balancer. Front ends and their related backend instances must always be in the same network. That means that the load balancer is geographically binded to a particular region, to a particular virtual network. There is no charge for using a basic load balancer, but the standard load balancer is charged based on the number of rules and the amount of data that is processed by the load balancer. Load balancer front ends are not accessible across global virtual network peerings. Always consider the new designs and new architectures when you consider using standard load balancer. We should also understand what backend pools are, and we'll understand that in the next lesson. When you're creating a load balancer, we gotta set up quite a lot of configuration for the load balancer. And yeah, it's just a one-time setup, but you don't have to worry about and maintain the load balancer time and again. But then we must understand various things like what backend pools are, what are load balancer rules, what's a session persistence, health probes, etc. In this lesson, let's go ahead and do some hands-on and understand how the load balancer works. So at this moment, I've created two virtual machines already, called them as Web Server 1 and Web Server 2. They are located in East US in the same network. Okay, so if I scroll to the right, you will notice that they are in the same virtual network called as mysite-vnet. Both of them are in the same private range, which is 10.0.0.0/24. And then of course they got different public IP addresses. Now, I just want to mention that they are in the same network and also in the same region. I've also set them up in the same availability set. So if I scroll down and look at a particular option called as availability set, you will notice that this is in an HA. Similarly, the web server 2 will also be in an availability set called as HA. So when I'm creating these virtual machines, I made sure that both of these are in the same region, number one. Second, in the same virtual network. They can be in different subnets though, but then they must be in the same availability set. All right, that being said, let's go ahead and connect to these machines and configure them as a web server. Okay, now keep in mind that these are Linux machines and they are not Windows, so I'm not going to do an RDP to them. For Windows machines, you're going to run your RDP on port number 3389, but because it is a Linux machine, I will go ahead and run an SSH on the public IP address. You can either run an SSH or use a tool called as PuTTY. So I will quickly launch the PuTTY tool on my machine. There you go. So that's the PuTTY tool. I will copy the public IP address and then connect to this machine. Just want to show you how you can make it a web server. There you go. Just click on yes, and then I will type in my user ID and then the password. Okay, that password is incorrect. I'll try one more time. Okay, there you go. I got connected as a root. I will clear the screen with clear command, and then now I'm back to the console. To make it as a web server, I will run the command called as sudo yum install httpd. So that is an httpd daemon that I'm installing. So when yum is not recognized, it can be apt-get. It's either yum or apt-get, just one of them. Okay, so HTTPD daemon is not recognized, so it is Apache 2. Well, it all depends on the kind of operating system you have. Now this is an Ubuntu flavor, it seems. Let's go ahead and verify. Yeah, it's a Ubuntu. So on Ubuntu machines, you're going to use apt-get. If it's Linux or CentOS, you will use yum along with httpd. But because it is Ubuntu machine, it has to go with apt-get and Apache 2. All right, so hit enter, and then I'll hit yes to continue. Okay, hit enter. It will take some time to deploy the HTTPD daemon on this machine or the Apache 2, and that will make it as a web server. Okay, now I have to just repeat the same activities on the second machine, okay, which I'll do that later. But on this machine, I have to first configure it fully. Okay, that means that I have to start the service. In Windows machines, when you install IIS, the web service automatically gets started, but in Linux, that's not the case. I gotta start it manually. So I'll say sudo start httpd start. Okay, okay, it's not httpd, it's Apache 2. Okay, so when you're working with multiple flavors of Linux, it's a problematic. So you don't have to learn Linux just for this purpose, but I'm just demonstrating how you can make Linux servers as web servers. So you got to run this command called sudo service apache 2 start. There you go. My service is started. I can just run a status here to see whether it's started or not. Well, it is active. So now all I got to do is pick up this public IP and put that in the browser and then paste it there, something like that. Now it's not going to work right now because in my security groups I have just port number 22 open. So I will quickly go to the networking and then security groups. I'll edit this to add port number 80. I just got port number 22 inbound. So I got to add an inbound port number 80 as well for the HTTP traffic. So I'll change this port to 80 here, and then maybe give the rule name as allow HTTP. That's it, and that should be good. And click on add. And once this rule is created, you would be able to access the website properly. Let's give it a minute for it to sink in. Now remember that we gotta set up the exact set of commands, exact set of configurations that we're doing on the second machine as well. Okay, so now you go back here and refresh the page. Okay, so it looks like that is ready. So this is my default web page of the Ubuntu. You can go ahead and configure it, customize it based on your requirements. For example, as per the documentation here, it says you can replace the file in the following path with your own index.html and it will work like your own website. I'll quickly show that to you as well. So I'll launch the Linux machine and then let's we'll clear the screen first and then navigate to this particular path here. Let's cd /var /www/html, hit enter, and then if I do dir here, well, in Linux the dir alternative is ls, like listing. Looks like there is an index.html. Okay, so what I have to do is remove this index.html and put my own index.html there, right? Because the current version of index.html has certain content like the HTML content which is more specific to this web page. We don't want this, we want our own custom page, so I'm gonna just say rm and then index.html. rm stands for remove, so I'll hit yes. So I got permission denied. It's more like run as administrator, so I'll do sudo here and now my file is removed. So now if I do ls, I do not have any file. So now I can use the vi editor to create a file called as index.html and hit enter. There you go. So my file is open. Now I'm ready to write certain content inside it. So I'll just call it as this is my new web server 1. Right, that should be good. I will close this file by saying write and quit and hit enter. It says cannot open the file for writing, and that is because again this is in read-only mode. I should have done sudo vi index.html. Okay, so I'll quit this particular file and then type sudo vi index.html, hit enter, and now this time I will type this is my, just say web server 1. Okay, should be good. and then just go ahead and close this guy, right? Say write and quit. There you go. So that's created. I will cat this index.html here, and now this is my web server 1. Now what do you think will happen if I go ahead and refresh this page? Do you think I will have the same content? Well, of course no, because I've deleted the default index.html and now I've got my own index.html in this page. Well, it could be any web page, it could be your custom page with your pictures, videos, etc. But at this time, I've made my own simple page. And now you can see that. I just refresh the page and you can see the content which I copied in the index.html from the VI editor. Okay, so now I'm going to pause this video and then run the exact set of operations for the web server 2 as well. So what I'm going to do, I'm going to go ahead and connect to the web server 2 using SSH, install the HTTP daemon or the Apache 2 daemon, start the service, open the VI editor, make my own index.html. At the same time, make sure that port number 80 is open on web server 2, right? So let's wait for a few minutes and I will be back after configuring the web server 2. Okay, so I've got the two web servers ready. They've been configured. They've got the ports open. So I'm able to access the web server 1 with the public IP, which says this is my web server 1, and the second one as well with the public IP, and it says this is my web server 2. Now it's time to connect them back with the load balancer. Now both of these virtual machines would be the backend pool of the load balancer. Let's go ahead and configure the load balancer and see how that works. Now I'm going to click on the load balancer button right here and then add a new load balancer. So we have the form here, the regular form that we always fill up to bill resources. Yeah. So my subscription will be pay as you go. Select my resource group, give this a name, call it as web load balancer or something, but make sure that you follow your naming standards of your company, your organization before you start naming some of these resources. All right. So I'm going to put this in the same region as my virtual machine, which is East US, and that is because my load balancers are region bound. So that means that I cannot have my load balancer somewhere sitting in, let's say, Central US and my backend pool, which is the virtual machines, sitting in East US. They must be in the same region. Okay, so I'm going to select the same region, East US here. And now we've got two types of load balancers, internal and public. That's what we learned in the previous lessons, that internal load balancer is for balancing the loads internally in your VNet or probably in your on-premise as well, if you have an express route or a site-to-site connectivity. And public load balancer is for public access, for e-commerce applications where you want people on the internet to access your websites. That's when you use public load balancer. The next option that we have is SKU, basic or standard. Well, with standard, you get a lot of good features. Like you can have zone redundant option here. You will have zonal front ends for inbound and outbound access. There's a lot of health probes and rules that you can write here. And the standard load balancer is closed for public IPs by default. So you need to have explicit rules to allow the traffic to flow into the standard load balancer, right? So it is much more secure, has got a lot of features. The basic one by default is open to the public. I'll select the basic one at this time and then make sure that my load balancer has a public IP. I'll say go ahead and create new and call that load balancer as maybe something called as load balancer IP. All right. And I want this IP address to be dynamically allocated or statically allocated. Well, in production environments, you'll always have static allocation to your public IP of the load balancer, right? It's because you do not want the IP address to change at all times. But because this is just a test environment, I will have a dynamic allocation. You can choose to have a public IPv6, yes or no here, but then I'm okay with no at this time. The next, you can configure the tags, and finally, review and create the load balancer. I'll click on create and then wait for the deployment to complete. It will take a minute to deploy this load balancer. We'll pause the video and connect again in the next lesson. The deployment of the load balancer is complete. Let's click on Go to Resource button and understand the various options we have to successfully configure the load balancer. In this lesson, we'll understand about the backend pools, the load balancer rules, the session persistence, health probes, the TCP custom probes, and various other options we have when configuring the load balancer. The first thing that you always got to check is the front end configuration. So I'll click on the front end IP configuration under settings, and you will notice that the front end configuration is already there. Now this is nothing but assigning a public IP address to the load balancer. So under overview, the public IP address must be assigned to the load balancer. It should not be a name, it should be an IP address. If you ever see a name, that means it's a problem. It's some time to troubleshoot. If you see a name like this, it means it is either not configured properly or it's time to troubleshoot. That's what it means. Okay. Now, because we have not configured the load balancer completely with the backend pool, with the health probes and load balancing rules, you do not see an IP address yet. So let's go ahead and configure the backend pool now. Now, if I click on backend pool, you will have the various options to add a backend pool for your load balancer. But what is a backend pool? To distribute the traffic from the load balancer to the ones that are assigned to the load balancing, you need something called as a backend pool. A backend pool contains the IP address of the virtual network cards that are connected to the load balancer. Well, it could be any one of these options that are there, like it can be a virtual machine or it could be a virtual machine scale set. Now, because we have a basic load balancer configured here, we are able to see just these two options. But if you had a standard load balancer configured, you can have an availability set configured as well here. Also keep in mind that in a standard SKU, you can have up to 1,000 instances in the backend pool. In the basic SKU, you can have 100 instances. Let's go ahead and configure the backend pool. I'll give the backend pool name as type backend pool or something here. And then the virtual network is that it is automatically picking my virtual network because my load balancer is in East US. And in East US, this is the only virtual network I have. So I'll click on that and then assign it to either a virtual machine or a virtual machine scale set. I'll click on virtual machine at this time, and then it will automatically show up the virtual machines that I have in that region in that virtual network. So that's web server 1 and its private IP address is automatically populated. I will also select the second web server and its private IP address. So when the traffic hits my load balancer called as web load balancer, it will then come and assign it to either web server 1 or web server 2 depending on how busy they are. I'll click on add to add and validate the backend pool. It will take a minute or so to validate and add the backend pool. So the next thing that we have to do that once it is ready is go ahead and configure a health probe. So while it is doing that and busy configuring the backend pool, let's understand what a health probe is. A health probe allows the load balancer to monitor the status of your application on the web server. The health probe dynamically removes any unhealthy web servers from the backend, so they do not participate in the load balancing act. So that means that when a probe from the load balancer to the web server fails, then the load balancer stops sending any new connections or any new traffic to the unhealthy instances. So there may be reasons why the server may go unhealthy. The reasons could be probably you are patching the server or the web developer is doing something with the web server that's made its connections bad. Maybe the services have stopped because you just restarted it. Maybe there's an antivirus blocking incoming connections. Well, there could be lots of reasons why the web server 1 could be unhealthy, but if that scenario ever happens, then we say that the load balancer will not talk to the web server. Well, there are several ways in which you can configure the health probe. You can configure it in HTTP custom probe or even TCP custom probe. We'll understand that when we are configuring the health probe of the load balancer. Okay, the backend pool is successfully configured now. We got two web servers here. Now I'll click on the health probes to configure the health probes. Click on the add button and then you will see that you got multiple options. You can configure it based on TCP or HTTP? Well, these are the two probes that I was just referring to. So when you select a TCP-based custom probe, it means that this probe will rely on establishing a successful TCP session on the defined port that you're defining here. So if the specified listener on the VM exists, so if port number 80 exists and it is properly listening, then the connections are accepted. If it is not listening on port number 80, then the probe will fail and the connections are not accepted, and that virtual machine will then be marked as unhealthy. We can specify the interval the probe should happen, which is the frequency of the interval. So that means that the load balancer will probe the virtual machine or the web application every 5 seconds, and it will consider it as unhealthy if it fails for 2 consecutive times. Let's also talk about the HTTP method of probing. The load balancer regularly probes your endpoint, which is every 15 seconds by default. So the instance is healthy if it responds with an HTTP 200 within that time period. Any status other than HTTP 200 causes the probe to fail. So HTTP success code is 200. And if you get anything apart from 200, like 303 or 404, it means that the probe will fail and that web server will then be considered as unhealthy. You can define the port on which the probe should happen, the path on which the URI request should happen. So the request will happen to check the health status on that particular backend path. And you can also define the amount of time between the probe attempts and the number of failures that must occur for the instance to be considered as unhealthy. If the number of failure attempts are more than 2, then it is considered as unhealthy. Of course, you can go ahead and change these numbers. These are the default values and also mostly used in production. But if your application or the business has different numbers to specify, you can add them here. I'll click on OK, but before that, I'll give it a name, call it as Health Probe, and then just say OK here. Now, by using an HTTP health probe, I'm saying that if the web server is not available on the port number 80, then consider it as unhealthy. Again, adding the health probe is not instantaneous. It takes a while to get that updated. And while that is getting updated, let's go ahead and talk about load balancing rules. A load balancing rule is used to define how traffic is distributed to the backend pool. There's a rule that maps a given front-end IP and a port combination to the set of backend IP addresses and a port combination. Now, to create this load balancing rule, we must have the front-end IP, backend pool, and health probes already configured. So now that we have a message here which says that the probe is created, I will go ahead and click on load balancing rules and then click on add. I'll give the rule name as LB rule here. Okay, and make sure that you don't give any spaces like me. And then the version is IPv4. I'm not using any IPv6s here. The front-end IP address is something that we already configured. It's available in the drop-down menu. I'm going to have all the traffic go on port number 80 TCP. The backend port on which my web applications are listening on is also port number 80. My backend pool is configured here and available in the drop-down menu as well. The health probe is something that we just defined. And then there's something called as session persistence. So what is session persistence? By default, Azure Load Balancer distributes the network traffic equally among multiple virtual machines. That is what it is supposed to do. The load balancer uses an algorithm called as 5-tuple. The 5 tuples here stands for source IP, source port, destination IP, destination port, and the protocol type. These are the 5 tuples. So this algorithm is called as the 5-tuple hash. The load balancer uses the 5-tuple hash to map the traffic to available servers. It provides stickiness only within a transport session. So do you want that stickiness to happen? Do you want the traffic to be sent to that particular IP only? So if the connection or the traffic is originating from a particular IP, let's call it as connection 1, and then if it lands up in virtual machine 1, do you want that connection to persist always? So the session persistence specifies how traffic from a client should be handled. The default behavior is none, and that means that successive requests from the client may be handled by any virtual machine. And you can change this behavior by selecting client IP or client IP and protocol. So if I select client IP here, that means that based on my client IP addresses, the traffic will be sent to a particular virtual machine only and not to all of them. So the client IP means that any successive requests from the same client IP address will be handled by the same virtual machine. But if I select client IP and protocol, it means that any successive requests from the same client IP address and protocol combination will be handled by the same virtual machine. Keeping the session persistence information is very important in certain applications. For example, using e-commerce applications that use a shopping cart. Okay, now these values are really important to configure the load balancing rule. I'll just click on OK here and wait for this to finish. Okay, now that the load balancing rule is added, it has stopped updating. We can see the rule here. I will go ahead and quickly click on the overview section here, and then I see the public IP address. And that's what I'm saying, that we need to configure all these 4 parameters to have the public IP address in place. What we can simply do is copy this part of the public IP address, or even maybe the whole part of it, and then paste it in the address bar and remove this particular section and then hit enter. There you go. So this traffic from the public IP address of the load balancer took me to web server 1. Well, you may hit refresh multiple times and you may land up on web server 2, but then looks like web server 1 is happy handling my request and it is not sending to web server 2 at all. But the objective here is to tell you that the load balancer can be connected to the backend pool. The backend pool here is nothing but the set of virtual machines that are there. You need to configure the health probes and load balancing rules to make sure that the load balancer understands which one of those virtual machine sets are healthy and which ones are not. Load balancer plays a very critical role in balancing the load between various cloud services and virtual machines.
Now that we know about load balancer, let's start discussing about Azure Traffic Manager. There's a lot of things that you expect from a load balancer, but unfortunately, Azure Load Balancer is binded to a particular region. What if you have resources across geographies? Let's say you got virtual machines and web applications running in different regions in different data centers, maybe some of them in the East US and then some of them in the West US. Today, with the advent of e-commerce websites and web applications, you know that these web applications are hosted geographically around the world. So your e-commerce applications like www.myproducts.com probably is hosted in some of the data centers in North America, some of them in Europe, and also in Australia. And all of these web servers are solving the same purpose, providing the products to the end users. If that is a situation and that is a scenario, then load balancer would not be of any help here because we know for sure that load balancer is binded to a region and it's gonna distribute the traffic only to the web servers or web applications in that particular region only. That's where Azure Traffic Manager comes to our rescue, and that means that it allows you to control the distribution of network traffic or user traffic to the endpoints running in different data centers around the world. Traffic Manager does that by using the DNS to direct the end user requests to the most appropriate endpoint. When I say appropriate endpoint, it would be something that is closest to the end users or how you have configured the Traffic Manager. We'll talk about the various routing methods in Traffic Manager in a bit, but let's understand the whole purpose of Traffic Manager, what it does, and all the good features it has. There are various endpoints that are supported by Traffic Manager, and that includes Azure Virtual Machines, web applications, and other cloud services. You can even host your infrastructure on your premise or in a different cloud. Traffic Manager can still direct the traffic to that web application. That means that you can use Traffic Manager with external non-Azure endpoints. So how does the traffic manager select an endpoint? Well, it is selecting the endpoint based on the traffic routing method. Traffic manager supports different kinds of routing methods to suit different application needs. Once the endpoint is selected, the clients then contact directly to the appropriate service endpoint. When I'm using this term called as endpoint, it just means the entity where your web application is hosted, like a Azure Virtual Machine, web applications, or Azure Web Apps or app services, and other cloud services. Just like Load Balancer, Traffic Manager also provides health checks and automatic endpoint failover, enabling you to build high availability applications that are resilient to failure. So that means that even if an entire Azure region goes down, the traffic manager still has the capability to direct the traffic to a healthy data center or a healthy region. There are certain specific ways you can use a traffic manager. Traffic manager will help you improve the availability of all your mission critical applications. And that is because it is constantly monitoring your endpoints in Azure and providing automatic failover when the endpoint goes down. And this will improve the responsiveness of high performance applications. Traffic Manager provides faster page loads and provides better end user experience by serving users with the service that is closest to them. So somebody sitting in Australia will be directed to the data center or the web service hosted in Australia. It will not go to the web service hosted in East US. This will be beneficial for administrators. Let's say they are performing service maintenance or upgrading their solutions in one of the data centers, then Traffic Manager will detect that and send the traffic elsewhere in a different region. You can also combine your on-premise and cloud-based applications. Like we said earlier, Traffic Manager supports external, non-Azure endpoints, and that enables to use hybrid cloud deployments or even on-premise deployments. Traffic Manager distributes traffic for large and complex deployments. It's important to understand the different routing methods that Traffic Manager uses. So in the next lessons, we'll be covering about the four basic routing methods like priority, performance, geographic, and weighted. These methods can also be combined to what is known today as nested Traffic Manager profiles. Azure has recently added two more routing methods. For example, multi-value and subnet routing methods. We'll talk about these one by one in the next lessons. Priority routing. Think about a scenario where your organization wants to provide reliability for its services by deploying one or more backup services in case a primary service goes down. Think about the organization that has multiple endpoints and they want to make sure that the traffic goes to one service endpoint at all times, but just in case that service endpoint goes down, the business must not be interrupted. The traffic must be routed to a secondary region for failover purposes. This is nothing but priority routing. And that means that in this case, the traffic manager profile contains a prioritized list of service endpoints. These endpoints could be web applications in East Coast or probably the virtual machines running an IIS server or maybe a Red Hat Tomcat service in one of the regions. Traffic Manager sends all the traffic to the primary, highest priority endpoint first, and if the primary endpoint is not available, Traffic Manager routes the traffic to the second endpoint and so on. Availability of the endpoint is based on the configured status, whether it's enabled or disabled, and the ongoing endpoint monitoring. The priority traffic routing method allows you to easily implement a failover pattern. You configure the endpoint priority explicitly or use the default priority based on the endpoint order. Just to summarize, priority routing means that if you're looking for a failover design in your web application routing of traffic, then that's when you will use priority routing. 100% of the traffic is going to one particular region. Just in case if that goes down, the traffic will be redirected to another site in a different region. Let's understand performance routing now. Think
Think about a scenario where you got your organization that has multiple locations to serve the traffic to the end users. If you look at this picture here, we got locations in West US, North Europe, and East Asia. And you would always like to make sure that the users are routed to the nearest data center to achieve the best responsiveness. Now, if you got a user in Denmark or probably somewhere in Europe, then we would like that traffic to be served to the end user from an endpoint that is residing in West Europe data center. And this will make sure that they experience the lowest latency and high responsiveness. The performance routing method is designed to improve the responsiveness by routing the traffic to the location that is closest to the user. The closest endpoint is not necessarily measured by the geographical distance. Instead, the traffic manager determines closeness by measuring network latency. Traffic Manager maintains something called as Internet Latency Table to track the round trip time between IP address ranges and each Azure data center. With this method, Traffic Manager looks up the source IP address of the incoming DNS request, in this case it is Denmark, and then it looks that up in the Internet Latency Table. Traffic Manager chooses an available endpoint in Azure Data Center that has the lowest latency for that IP address range, and then it returns the endpoint in the DNS response. Remember that the Traffic Manager does not receive DNS queries directly from clients. Rather, DNS queries come from the recursive DNS service that the clients are configured to use. Therefore, the IP address used to determine the closest endpoint is not the client's IP address, but it is the IP address of the recursive DNS service. In practice, this IP address is a good proxy for the client. Let's understand the geographic routing in the next lesson now. In certain situations, knowing a user's geographic region and routing them based on that is very important. Certain examples of that would be when the user needs local content in their local language. Or probably we as an admin want to improvise on the user experience. Or maybe you want to measure the traffic from different regions. Or you want to comply with data sovereignty mandates. In any one of these situations, you may want to route a particular traffic to a particular geographic region. When a traffic manager profile is configured for geographic routing, each endpoint associated with that profile will have a set of geographic locations assigned to it. Any request that is being originated from that region will get routed to that endpoint only. If you look at the picture here, we got multiple endpoints. There are endpoints in Germany, some of them are in Mexico, Asia, and some of them may be in the whole world. Some kind of planning is required when you create a geographical endpoint. A location cannot be in more than one endpoint. Your routing can be done based on entire world or a particular continent like Europe, Middle East, or Asia, or the routing can also be done based on a country. For example, you may want the traffic originated from Middle East to go to, let's say, endpoint 2 in this case. Traffic originated from Europe must go to Germany. Traffic originated from Asia, in this case, has a nested profile where we are saying that it can go to either priority 1 or priority 2. If you look at this particular diagram here, we have nested the profiles with geographic routing and a priority routing. And this means that any traffic originated for Germany or the entire world, except that it's going to go to the nested profile, which will then end up in either endpoint A or endpoint B. This is an example of nested profile as well. So with geographic routing, we are routing the traffic to a particular region, ensuring that the clients get not only lowest latency, but they get the local content, they get the better user experience as well.
Let's understand the weighted routing method in Traffic Manager profiles. At times you may have multiple endpoints. Let's say you got a website called Test A and another web application in region B. In this scenario, you may want to use weighted routing for multiple reasons. The reason one is, let's say if you would like to equally distribute the load between these two web applications. Another reason may be if you would like to gradually increase the traffic over time. So initially you may want to say that, okay, I'm going to distribute the load between these two on 50-50 basis. And that means that traffic between these two web applications will be distributed equally. But let's say in this example, you got three web applications. The one that is hosted in region A, another one in region B, and a third application which is test A. Now, if you are testing or bringing a new endpoint online, you may want to gradually increase the traffic over time to the new website. So that way it is not a big bang deployment and the customers will also not be bombarded with new features of your applications. So weighted traffic routing method allows you to distribute the traffic evenly or based on the number that you define. That number would be considered as weight on that application. In weighted traffic routing method, you assign a weight, which is nothing but a number, and that number is assigned to each endpoint in the traffic manager profile configuration. The weight is an integer like we just said, and it ranges from 1 to 1000. Now this parameter is optional, but if you ignore this value, then Traffic Manager uses a default weight of 1. The higher the weight, the higher the priority. Using the same weight across all endpoints will result in an even traffic distribution. Using higher or lower weights on specific endpoints causes those endpoints to be returned more or less frequently in the DNS responses. So weighted routing method is a method where you would like to prefer one endpoint over another endpoint, depending on how much load would you like to send to that particular endpoint.
All right, now that we understand certain traffic manager routing methods, let's go ahead and do some labs to understand this better. We'll go ahead and understand various checkboxes and radio buttons we have in the traffic manager profiles as and when we get along those options. All right, for demonstration purposes, I've created two web applications under app services. Call them as ecom site 1. Another one is ecom site 2. You will notice that these web applications are hosted in two different geographical regions. Now let's see how we can connect these with the help of Traffic Manager. Now to create a Traffic Manager, in the search box, I'll type Traffic Manager Profiles and click on this purple icon that says Traffic Manager Profiles. As always, you can either click on Add button or Create Traffic Manager Profile and start filling up these values. Make sure that the name that you give to your traffic manager should always be unique and nobody else in the world must have chosen it. But just in case if you bump into any conflicts, the screen will just show the error right away. So let's give it a shot. I'm gonna give it name as traffic manager. Alright, so looks like somebody has already picked up this name, trafficmanager.trafficmanager.net. Put your mouse on the red thing and you will see that the domain name has already been picked up. So let's give it a smaller name, Trafman or something. All right, somebody's getting creative there. That web application, that endpoint has also been picked up. I'm just going to put some numbers next to it. All right, there you go. So this is accepted. And now these are the routing methods that we discussed so far. There's performance, weighted, priority, and geographic that we understand. But look at that, you got two others, multi-valued and subnet as well. Now let's understand these two options here. Now the multi-value traffic routing will allow you to get multiple healthy endpoints in a single query of DNS. So this will enable the caller to do certain client-side retries with other endpoints in the event of a particular endpoint being unresponsive. And that means that this kind of pattern will increase the availability of a service. And this will also reduce the latency that is usually associated with a new DNS query to obtain a healthy endpoint. Now there's another one called a subnet. This subnet traffic routing method allows you to map a set of end user IP address ranges to a specific endpoint in the profile. So if the traffic manager receives a DNS query for that profile, It will inspect the source IP address and see if that exists in that subnet. If it exists, that's when the traffic will be allowed to that particular endpoint. The subnet routing method can be used to deliver a different experience for users connecting from a specific IP address space. For example, if you got your customers making requests from a particular subnet, you can route that traffic to an endpoint. Probably maybe your corporate office is routed to one endpoint, whereas the rest of the public is routed to another endpoint. So you will have certain set of users in your office doing the testing, and hence they will be routed to a testing app, whereas other users may be routed to the production app. That's when I will use the subnet routing method. Alright, now that we understand the various routing methods here, I'm going to select weighted for example and continue through this wizard. I'll leave the subscription as pay as you go, the resource group, so we'll select my site and then click on create. It's going to take a minute to get that published on my Azure subscription. I'm going to pause the video and then connect once it is ready. So there you go. I've got my traffic manager one-to-one created and it is in weighted routing method. Let's go ahead and click on it, drill down further into the options and understand how Traffic Manager works. The first thing that I'm going to do is look at the DNS endpoint. So any traffic that needs to get into my endpoints has to go through this DNS name, which is http:// your traffic manager name dot trafficmanager.net. Now, when the traffic hits here, it's going to go and redirect the traffic to something called as endpoints. In the endpoints, I need to configure my endpoints that we created earlier. Remember, we created two app services. So I'm going to connect those app services to this traffic manager. I'll click on add and then let's go through these options that we have here. The endpoint that we have is of primarily two types. One is an Azure endpoint and second one is an external endpoint. So if you got your endpoints hosted in Azure in your subscription, you might want to choose Azure endpoints. Examples for this could be your load balancer or even a virtual machine. An external endpoint is a kind of endpoint which is outside your Azure subscription. This could be anything that has an FQDN. It could be application that is not hosted in Azure as well. A nested endpoint is where you would like to connect other traffic managers configured in other traffic manager routing methods. For example, this traffic manager is configured with weighted routing method. And let's say the traffic that gets into this traffic manager then gets into an endpoint, which is nested endpoint in, let's say, priority method or performance method. So you can have as many nested endpoints as possible. So in this case, we got our endpoints in Azure. So I will select Azure endpoint here. I'll give it a name, call it as endpoint 1. And then the target resource type can be a cloud service, an app service, an app service slot, or a public IP address. In our case, I've got an app service, so I'll select that. And when I click on the target resource, it should automatically pick up the endpoints that I have as far as app services are concerned. So I'm going to add them one by one in each endpoint. So selecting e-commerce 1, and then in this case, I'm going to give a routing method of 50. So once I have the weight selected, I'll just click on OK for this to set an endpoint for me. And once that is done, I'll go ahead and add a secondary endpoint. There you go. So I've got the one endpoint here. I'll click on add and then quickly add the second endpoint, calling it as endpoint 2. Yes, it's a cloud service. Okay, it's an app service. So I'll select e-commerce site 2 and then the remainder of my 50% of the traffic will go to this secondary endpoint, which is ecom site 2. I'll click on OK. And now I've got both of these endpoints connected to my traffic manager. So what does that mean? It means that any traffic that hits and gets into http:// it will be redirected to the endpoints that I've configured out here. The traffic will be load balanced between them on 50-50 basis. You can also go ahead and look at the configuration here and then change the routing method from weighted to performance, let's say, or priority. But there are other important options, for example, the DNS time to live. Time to live is the amount of time the DNS client query will be cached in your client machines. So it looks like 60 seconds is the default amount of time the client query will be cached on their machines. The traffic manager also has certain health information just like load balancer. If you recall your load balancer session, we were looking at the health probes. When should the load balancer send the traffic to the endpoint? Similarly, for traffic manager as well, the traffic manager will send the traffic to the endpoint only if they are healthy. So here are the certain health rules that you're configuring to make sure that the traffic manager sends the traffic to healthy endpoints only and the unhealthy endpoints are totally ignored. You can take a look at the traffic view, and this is a new configuration here, and you need to enable this traffic view. And this will make sure that any traffic that is going between your traffic manager and the endpoints is something that you can see. You can see where the traffic is originated from, how much latency do the users have. So by looking at these values, you will be able to fine tune your application and then also understand the user experience. The whole traffic manager section may appear like a load balancer, but keep in mind that traffic manager and load balancer, although are distributing the traffics between the endpoints, they are totally different and they are operating at two different layers of the OSI. We will understand the difference between traffic manager and load balancer in the next lesson. But for now, the takeaways from this lesson is that we understood to configure the traffic manager, connect the endpoints to it, and then also the configuration section where you can write down the health probes that the traffic manager can send to the respective endpoints that you've configured right here.